Hey guys, welcome back. In this video, we're going to be doing this packing inventory challenge. So the goal, like the topic is inheritance. So we're going to create a pack class to hold all of our items. And then we're going to create an inventory item class. That's going to be our base class. And then we're going to create a bunch of different derived types based on this data here. And the pack is limited by item count, weight, and volume. So if we run out of space in any of those, then the pack is full and we're done adding stuff. And that's what this method here is supposed to do, which is attempt to add an item, and if it, depending on if it succeeds or fails, we'll return true or false. And then there's a little bit more here that says to allow the user to pick items until the pack is full. That part is more about user input than it is about the inheritance, but we'll do that too. All right, let's get into this. I'm going to move this off the screen. And we'll just start going here. So the first thing we need to do is create I'm gonna, just so this still compiles, give it hello world, and then we're gonna make a class, public class inventory item. And it says this class must represent the item's weight and volume, which it needs at creation time, which means the constructor. So I think public let's see, public doubles or floats. Like we could use either one. I'm feeling in the mood to do double today. It's a little more space. It's a little more accurate. The volumes, the weights, like the things we're talking about are really not, don't really need that. Maybe I just talked myself into a float. It kind of depends. And like if we were doing this as a part of a bigger program, a lot of times there will be some sort of compelling reason to use floats or doubles. And if the program as a whole has a compelling need to use float or double, I would probably generally, like in this case, just say, well, the whole program, it tends to be using float or double, so I'm going to use that again here. In this case, like I said, it's float is less precise and fewer bytes, but on modern computers, we usually have a lot of bytes, so it's not that big of a deal one way or another. But public float weight, it's not settable, but it is gettable. Float vol. All right. I do want to say that, like, the book, the challenge description doesn't say anything about like the units of this, so they can be whatever you want. Or does it? Hang on. Yeah, it just says like an arrow has a weight of 0.1 and a volume of 0.05. So like these are just, I mean, maybe it's kilograms and cubic meters or centimeters, or like I don't know what it doesn't matter. If you were doing a much bigger thing, like maybe some of these things start to matter, or you might want to like make sure that it's realistic. In this case, it doesn't matter. So all we need here is a inventory item, a constructor that allows us to pass in the our two parameters. And there is our base class. We don't need to, but we could make this abstract. By making it abstract, we are saying, look, nobody should be able to create a plain old inventory item, right? That like you must specify, you must create something more specific than that. And that may, like, it makes sense here. Like you don't want an inventory item that is meaningless. You want an inventory item that means something. So I think it makes sense to make that abstract. And then it's time to make our derived classes. So public class, these can't be abstract. So for each of the items above, so public class arrow And then we're going to use our inheritance. So we just say this is derived from inventory item. Now the compiler immediately is telling us, hey, you got an issue. The base class doesn't have a parameterless constructor, meaning I don't know. The compiler wants to generate a parameterless constructor for this arrow class, but that default constructor would normally call the base class's parameterless constructor, and there isn't one. There's only this one right here that has 2 parameters. So this is saying I don't know what to do here. So you basically we're going to have to like specify how that works. In theory, you could do something like public arrow, like give ourselves a constructor, and then like it's not uncommon for like to like have our constructor pass in parameters for these things, except that we've made like the description in the challenge is very clear that you're not like the programmer that's making a new arrow should not be able to choose the weight and volume, nor should they they shouldn't be forced to make that choice either. They should be able to just say, I just need an arrow, and that it would tell you what that is. So in this case, what I'm going to do, so first of all, we're going to say, well, because there isn't a parameterless constructor to use as a default, we've got to be explicit about what we're doing. So we come here, it says this is going to chain off of this specific one in the base class, and it's going to be, our values for, this is going to call this one here, so our weight and our volume. And for an arrow, that was 0.1 and 0.05. And all of a sudden, I'm seeing a reason why I might actually prefer to make those doubles. This is a float. This is a double literal. And so I can stick that on there and we're fine, right? Like now it's a float literal with that F on there. But I wouldn't mind keeping that simple and not having to put the F's on there. So maybe just, like I said, it was pretty arbitrary in the first place, and maybe I'll just change these over to doubles really quick. There. Now I can just do 0.1 and 0.05. And that's it. So now if I came up here to my main method and I said, well, I want to create, arrow a equals new arrow. So now, now I can just create a new arrow with just that line. I don't have to pass in values, which actually we didn't want, right? Like we didn't want to require anybody who wants to create an arrow to have to write in these numbers. That kind of defeats the purpose. Arrows are in this specific program, arrows and all the other, rope and all these other items are meant to be a very specific weight and volume. So we shouldn't need to do that. We should be able to just say new arrow, and like it just knows its weight and volume, which it picks up right here. So that's what we're doing. That's what we should be able to achieve. And we can do this console.write line a dot weight and a dot volume. And now we should be able to run this. By the way, well, let me run this really quick and then I'll say what I was going to say. So now you can see weight equals 0.1, volume equals 0.05. The one thing I was going to say is this approach of like I'm not done. I haven't completed the whole thing, but I'm able to do a sanity check by writing just the minimal amount of other code to test out what I'm writing is a very common thing that programmers do. Don't feel like, especially on these challenges, like this is not a tiny challenge. I mean, this one's worth 150 XP. it's not a tiny challenge. It's actually kind of big, and there's a lot of moving parts to it. So don't feel like, well, I got to write out all the code before I write my main method, which was supposed to like do user input. Like, no, we don't need to worry about all that. We're okay. We can just start testing it now and make sure like, does it look like it's right? Yeah, it does. All right. So I feel like I'm gonna simplify that a little bit because it's just one line. I don't need this to do anything else. And I'll come back to that in a little bit. So now what I'm going to do is add in all my other types, right? So we have an arrow, we have a bow, we have how many of these do we have? There are 6 total. I've got 2, 3, 4, 5, 6. So I have my arrow, I have my bow. The next item is a rope. Next item is it's water. Food. By the way, I'm doing this like multi cursor editing. I know I've talked about this in other videos, but not everybody watches all the videos. You click somewhere, and then if you hold down, it's muscle memory at this point. If you hold down Control and Alt, I'm holding down Control and Alt, and then I click in another place. Then I get a second cursor. And now if I hit backspace, like I'm modifying in 2 places. So that's really convenient. All right, so now I've got all my different types here. Arrow, bow. In this case, the bow is 1 and 4. The rope is 1 and 1.5. Water is 2 and 3. Food rations is 1 and 0.5. And then the last one is a sword, 5 and 3. Oops, 3, there. So now I've got all my derived types here. And now I should be able to create these as well. So in fact, what I could do here is I can say inventory, I can spell right, inventory item, an array, items equals new inventory item. Well, let's do it. Well, okay, let's do it this way. New bow, new sword, new rope. Poof. And now I can just say for each inventory item in items, console.writeLine, item.weight, item.volume. The catch here is I'd actually kind of like, for what I'm doing here, I'd like a name, right? Like, what is this thing? Well, there's a few ways we can do that. The default string representation of an object is the name. So in theory, this should get us what we want. Yes, bow, sword, rope. Like that works to get those things. What I will say is we haven't dealt with namespaces, but like if you've put this in a namespace, if I'm not mistaken, I think that it includes, it's the fully qualified name, so I think it includes the namespace name. So bear with me while I write some random code here, but um, to test out my assumption. So if I throw these into a namespace and then run it again, I think it'll tack that namespace on. Yeah, so easy. Some namespace.bo. So like obviously you don't need namespaces. We haven't covered namespaces yet. There's no need to like worry about that. But what I will say is a lot of like for something that you're doing just for your own learning, it's totally fine to like see code the fully like the names of code elements show up in your console application. You're the only user of the program right now, so it's totally fine if you end up with something like whatever that was, some namespace dot arrow. Who cares? Like it's what you needed. But for something more real, you don't necessarily want the code elements to always align with the what the user sees. And a good example of this is, I mean, you could say this about any of these, like the capitalization of these things is not necessarily what you want the user to see. You might want that to be lowercase for something. And so I've seen some people do something like this. They say, well, to get the name right in my text, I'm just going to rename this to lowercase arrow so that when I like to string the thing, that's what I get. So it's capitalized right. But like there's limits to that. And the biggest limit is this, like you need a space there. But it goes beyond that. Like you might want the you might want to call this in the user interface, including a console user interface, a command line interface. You might want to call this not just a sword, but like, I don't know, broadsword or something like that. And you don't necessarily want to force your code name element names to always be aligned with what the user sees. So I usually just like for what I'm doing here, I don't really care. I just wanted to know that I've actually got a bow and a sword and a rope, and the rest of it, I don't care. Like I'm fine if it looks like the code, but if I want that nuance, then what I'd probably do, even though the challenge doesn't say this, I'd probably do something like this: public string name, and add a parameter here, and now I have a name, and then I just pass in whatever the name is that I want for this thing. So in this case now I have the ability to have that nuance with the space in there. I had the ability to uh, like deviate, not just by changing, adding in a space or changing the capitalization, but by just using a completely different word. I could call it anything I want. I could stick in there, and now up here I can just say type equals name, and maybe then I'll rename this to name, something like that, and now it'll be whatever I had given it. Okay. Now that we have all of these derived classes, there's something else I want to say about this whole inheritance thing. And that is, if this was literally the end of it, like if I didn't need to do more than what I've got here, I actually don't think I would use inheritance. If the only way that types differ is the values that they're using, it's simpler to just do like kind of like what we did with the arrows, Vin Fletcher's arrows, and like the factory methods. Like it'd be probably better to say, well, you know what? I'm going to make that not abstract, and I'm going to make like a static factory method, public static inventory item create arrow, and that this would just return a new inventory item with the name arrow, the right weight, the right volume, and that's it. And that is much easier to like. We just have this, and then we don't have this pile of classes. And you can see like there's a lot of overhead. Like there's a lot of code that goes into having these classes. So if the whole purpose was just I need objects that have different like data values, usually you wouldn't want to make other classes. Now this is again, it's practice. Like we're trying to get some experience making classes, making derived classes, deriving from things. This sort of idea here where like I have an array of that's contains inventory items, and I can put a bow and a sword and a rope in it. And so we're getting experience with those things, and that matters. Like that's the reason why we're doing this in the first place. But if outside of the constraints that this challenge gives us of this is what you need to do, you need inheritance, I would probably skip that. Where you want the inheritance is when your different inventory items have additional members. I'm trying to think of a good example of that, but I mean, maybe the rope has a length. Maybe uh, the food rations has a like an enumeration that's like the cuisine. Like, is it is it is it elvish food? Is it orc food? Like whatever it is, like maybe it has that. I don't know. Um, like once you start having these additional things, then it starts to make sense. And we don't and won't, frankly, have that in this challenge. That's okay. Like I said, think for all these challenges, think bigger about like what could be if you just imagine that this is something that is part of something bigger. Because everything that we're learning about in part 2 is really about that. It's about as we build bigger programs, these tools get useful. So I'm gonna kind of undo this. I don't want that, and I actually do want to keep this abstract, like I said, in just because that's where we're trying to go with this. But that should solve the problem. Also, before I move on, I want to mention, like you can see some of these things here. Well, that right there, declare types and namespaces. That one is about what I said about the namespaces. Don't worry about that. That's not even a warning. The CA ones are analysis, code analysis. So these are things that's like, it's best practice to do it this way. We haven't talked about namespaces. I wouldn't worry about it right now. But this right here, convert into primary constructor. This is a C# 12 feature. And so if you're like the 5th edition does not cover that. There is, if you aren't aware of this, there are 2 expansions right now, C# 11 expansion and C# 12 expansion, that cover the C# 11 and 12 features. C# 13 comes out right now. This is July of 2024. So November of 2024, a few months from now. So depending on when you're watching this, there will be C# 13, and I will make sure that there is a C# 13 expansion as well. Anyway, this is suggesting use a C# 12 feature that I think actually would simplify this code a ton. And I'm actually going to like do it. And this is primary constructor. I don't want to get too much into like the C# 12 feature, other than just to say that, like, yeah, this is a good idea. Like, now that that feature exists, it makes sense. I'm gonna just push this button and it's just gonna do it. Poof. And like, so now instead of having like all the extra lines for like the constructor, it just, they move up here, and then this, like, now in here we have access to those. So we initialize all three of these properties to that. It gets better when I come down here, convert to primary constructor, simplify constructors in class arrow. Poof, like now this whole class is a one-liner, and I can do that. In fact, it's going to give me an option, I think, to do it in the whole file. Yep, or like if you simplify constructors in file. So poof, it's going to do it to all of them. So that code just got a whole lot shorter. And like I said, this is exactly identical code to what we just had. So I definitely like this. I think it's a good simplification. It's definitely what I would do in a C# 12 world. My code online didn't have C#. Like, I didn't, when I wrote my solution that I posted online, this wasn't an option, so I definitely didn't do it that way. But it's definitely a lot less code. And if you want more stuff in here, you can still do it. But yeah, I definitely like how short that got. I'm going to undo this, though, just so that we don't do too much. Like, with this, my goal is with these videos is never to make it exactly like what I posted online, and by kind of by design, and something that's just that I want people to see. Like, there's more than one way to solve this. So, all right, we're back to here. I've got my classes, and what I need is the pack class. So I've finished the first 2 bullet points, and now I need a pack class. So public class pack, and this can store an array of items. So this will be like public. It doesn't necessarily have to be a public property, but I don't mind it being a public property. Like, if I think about, like, yeah, we don't need access to those items, but it makes sense when I think about what would be useful for this pack class. It makes sense to be able to see the items that are inside of it. I do worry a little bit that means that somebody could hijack the hijack it and do something with it. That's one of the limitations of arrays. There are other tools that we'll get to later that would allow somebody to what I mean by that is somebody can take a reference to a pack object and then just directly like change or remove items or whatever from the array itself. Again, I won't worry about that right now. There are solutions to it, but that's beyond the scope of what we're trying to do here. I do think like those can be null, so I am going to express that. And then we just need a constructor, a public pack. So this this gives us our total number of items, the maximum weight, the maximum volume. So int max items double max weight double max volume. And then I'm going to, so one thing I'll do is I'll say items equals new inventory item of the max items. So this will make a new array for our items. You don't want to forget that, or this will be null. And now that this is of that specific size, like we know that's all, we've got that many items. We won't put too many items in it because there's not space. The array is only big enough to hold that. And then I'm going to make properties for public double max weight. I don't need that to be settable. as I'm thinking about it, I actually like the name total weight, total volume. I might want to rename those. I'll leave them. They're fine. But I do want to save those off. So there, we've got them saved. And now we want to public add in our this add method. Public bool add inventory item. All right. So at this point, the idea, and I'm going to come up here and say pack. We ought to be able to make a new pack. Let's say we have 10 items with a max weight of 10 and a max volume of 15. We won't be too boring. And now we can come in here and say item in items. All right, so now we can say something like pack.add new sword, new bow, new rope. So in theory, this should give us more or less what we had before, other than this add method doesn't actually, and we just say I'm stubbing it out. It's not doing anything useful yet. The pack is going to stay empty because we didn't add anything in. Oh, what is null here? Oh, yeah, okay. It's the pack's items. I can actually, if I hover over this, I can see that it's an array and it's got the right number of elements, but they're all null. So I should check this for null. In fact, that is, if I look at the warnings that I do have, it's telling me that converting null literal or possible null value to non-nullable type. And it is that second part, that possible null value. Items might be null. So I should keep this null, but then now I've got this one that it says, look, it could be null. So what I should do is do if item is not null, then do this. Now, the way I've written that with like this indentation, not everybody likes that. I don't mind it too much, but like some people don't. Once there's like multiple lines underneath it, some people will be like, let's get these curly braces in there. And I don't disagree with that. In fact, some people will just say there should just be curly braces in here for all of it. I like it, especially if you make that mistake of accidentally thinking that the indentation is like, anyway, that's a whole other thing. I won't get into that. Anyway, point is now if we could actually if this would actually add the items, we'd be good. So let's add that. So we stubbed it out. We got to do something useful with it. What we need to do is if we can get the items into this items array, then this code should work. Easier said than done, because right now, like I can just say items index 0 equals the item, right? And then return true. The problem is like we'll add a sword and it'll place it in index 0, and then we'll do the bow and it'll add it in at index 0, which will replace the sword, and then we'll do rope and add it in at index 0 and replace that. So now we'll just have the rope in there because it was the last thing, which isn't what we're going for. And so the real question is, well, where do I add it? One thing I'll say is we're not quite to the point of being able to use lists. A list just hasn't, you don't have to like add it at a specific index. You can just say add. So once you get to list, this thing gets easier. But I don't think it's bad to like struggle with arrays because everything, like a list uses an array. And so to think about how the system has to handle this stuff is, I think it's good mental strength training. It forces you to think deeper and harder about these things for a little while until we learn the tools. So the saving grace here is that we need to be keeping track of how many items we've got and how much our current weight is and how much our current volume is anyway. So what if we just add in, and we could do something like this, private int current count equals 0. So we just make a new field for the count. And so now at this point, we can say current count, and then current count plus plus. We just increment it. So now there will be one more item in here. Our current count goes up to 1 after this, and then the next time we come in here, it'll be 1, and we'll add it to index 1. All right. So now we should get our 3 items. Good. Looks like we did. The catch is I could come in here and add, more items, enough items that'll run past the end of the array and it'll blow up. I'll run that here and you'll see it. Poof. Index at a range exception, because there's not space for 10 items. So now what we want to do is say if current count is equal, well, and we can say greater than or equal to items dot length. Move that out of the way. Return false. So if we've gotten too far, then return false. Now I ought to be able to just move that little yellow thing up here and just say run this again. We can step over that and it should. So yeah, I hijacked it. The program had reached this point here, but because of the cool debugging tools that we have, there's a whole chapter about that at the end of the book. If you haven't been through that and don't know how to debug, it's a good thing to jump ahead to and take a peek at. And I just dragged that yellow arrow up here. That's it's a little bit dangerous, but it's super powerful. And I just said, just start back up here and run it again. And it did. And now it'll just return false. So it won't actually add it. So now all these next items are like, they're not gonna get added. So I got my sword, my bow, and then 8 ropes, but not all the rest of these. The rest just failed silently, which is maybe exactly what we want. But the other thing that we want to do, it isn't just the count that we want. There's also we want to limit ourselves by weight and private double current volume equals 0. And so so also in here, what we want to do is when we add an item, we want to say current volume. We want to add the new item's volume. So we can just say plus equals item dot volume and current weight plus equals item dot weight. So now our current volume and current weight will also be updated. And I'm gonna do this for the moment. It needs a tweak. But if I just say if current weight is greater than max weight, return false. And then if current volume is greater than max volume. So if any of these conditions fail, then we just leave. We just stop and say, look, it didn't work. So what was our heaviest item? I think it was a sword, right? Yeah, sword has a weight of 5. So if I add 3 swords, we'll max out our weight, but not our volume. Yeah, not our volume and not our items. So in theory, we should only get 2 swords in here. Well, let me actually, I'll start here. Like in theory, we should only get 2 swords. But I do want to, so let's run this. What we got was 3 swords. Well, why? It's because well, you might think, well, maybe I just need these to be equal, but that shouldn't do it. Let me make sure. I lied. Let me do it this way. So a rope has a weight of 1. So this is 5, this is 1, this is 5. So we shouldn't be able to include the weight of 2 swords and a rope, right? Where our max weight is 10. But see if I'm surprised again. Yeah, okay, good. It was actually able to get all of these added. It wouldn't add the next thing, even if we pick something light. What's something light? An arrow, right? So if we add something light, it will reject the arrow. And that's because it's because this check here says, well, as long as I'm not already maxed out, I can add anything, including something really heavy that would push me way past my limits. We're not doing the check. We're doing the check of, well, what do I already have, not what would it be if I added it. So what we should do is like peek ahead and say, well, what would the weight be? So if current weight plus item dot weight. So if we peek ahead, if the new item's weight would push us over the limit, that's when we want to stop, right? And we'll do the same thing with volume. Wow. All right. So if this, like, and we could in theory do the same thing here. So if current count plus 1 is greater than the number of items that we allow, that makes them a little more symmetric. If you care about that, I might even do that. Sometimes adding some white space makes it easier to understand, and sometimes it makes it harder. So sometimes I just try it both ways and see what I like. All right. So now, notice what happened. I was able to add the first sword. I was able to add the rope, and then the next sword would have put us over the weight limit, and so that got rejected. And then we were able to add an arrow. So the code is now more or less doing what it's supposed to do. Like it enforces its own limits about what, the weight, the volume, the item count limits. And in theory, the only thing that is left is for us to make it so that the user does this part right here. I've seen a lot of people do some really clever things in terms of like user interaction here. I'm going to try and keep it pretty simple. And what I'll do is I'll say, so while true, and like we could bail early or bail once the pack is full. It's just like it's a little hard to know when it's truly full, because what if there's an item that is, I guess the only thing that's like a hard limit, well, for example, we could add a sword and not be able to add more swords, and then we could add a sword and a bow. What is bow? A sword, 4 bows, and then we could add, like, the arrows are really light, so we like add a ton of arrows. Like, just because one thing doesn't fit in doesn't mean lighter weight things or smaller things couldn't fit in. So it can be a little tricky. I'm not going to worry about that. I'm just going to let it run indefinitely, and then I'm going to say pack dot. So let's see. We'll do console dot write line. What do you want to add to your pack? Um, and I'm gonna let people freeform type it in, which is probably a really dumb idea for like deploying it out in the wild, just because this is going to be so easy to mess up. But it better, like, I don't want to spend a ton of time doing user input here, because it's useful, it's good practice, it's kind of beside the point. So what I'm going to do is string input equals console.readline. So we'll read it in, and then we'll say we'll make, so inventory item possibly null, new item equals input switch. I love switch expressions. So here we'll say if it's an arrow, they type in arrow, then we'll say new arrow. If they type in bow, new bow. If they say rope, new rope. If they type in water, new water. Food, new food rations. And if they type in sword, new sword. And if they do anything else, I'm going to let this whole thing evaluate to null. And so this legitimately can be null. So then what I'll do is I'll say if new item is null, console.writeLine, I don't know what. Well, let's do this. I don't have any in stock right now. And then I just want to go again. But so if they didn't enter in anything good, then we're just going to let it. We're just going to let it then try again. But otherwise, we're going to attempt to add it to the pack. So pack.add new item. But what we'll do is we'll say if pack.add new item. So if that will return a true or a false, and it returns true if it was successful. So if we added it, console.writeLine, and we'll do new item, dot name has been added to your pack. Otherwise, console.writeLine. That doesn't fit in your pack right now. All right, a lot of user input. Let's run this, see where we're at. What do you want to add to your pack? So again, I'm going light on the user input. I think that is probably advisable. Again, we don't have all the tools yet to really do good user input. Keep in mind that the whole point of all of this right now is not to have this bulletproof program that you could ship to, people around the world that everyone will pay you $1 million for. It's about learning C#. So the user input is useful. It's certainly good practice. But like I said, I'm taking a shortcut, and you should do as much user input handling as you want to spend the time on. Unless the topic is specifically about user input, as long as you check the boxes on what the challenge is asking for, you can keep it pretty lightweight, allow people to type in garbage that crashes the program, just rerun the program. Anyway, what do you want to add to your pack? So I have to, again, the user, they have no clue what the options are, but I can see them right here, so I know exactly what they are. So I'm going to type in bow. Bow has been added to your pack. What do you want to add to your pack? Another bow, another bow, another bow. That doesn't fit in your pack right now. All right, so I've added, how many did I add? 1, 2, 3. They were each 3, right? Oh, volume of 4. Oh, yeah, volume of 4. Hmm. Yeah, okay. No, that makes sense. So bow has been added to your pack. So we added one right here, one right here, one right here. And then we try to do it again. So the volume of a bow is 4. 4 times 3 is 12. And the next one would have put us over the limit. But we do have space here for arrow. And now at this point, we should be maxed out. So no matter what we add. The only thing that might be nice is, yeah, I mean, that's all we need to do. But it might be nice to know like what is in there. Because like right now, the only way I can actually find out what's in here is, it's like put a breakpoint right here. And then wait until I hit the breakpoint. And then I can mouse over the pack and see what items I have. So it might be nice to kind of take this code down here. In fact, I'm going to void display. I'm going to kind of rework this code into a method to display these contents. Oh, and then display the pack. So it tells us what we've got. What do you want to add to your pack? I guess the other thing that might be nice is it'd be nice in here. Is to get like the something like that. For the weight, the volume, I'm going to call that count instead of items. All right, something like that. And then, but then the problem is my pack class doesn't have any of that. Well, it actually does. It's just that they're all this. So if I promote these to yeah, so I have my items, and then I have my maximums and I have my current ones. These get maintained, these get updated in this right here. These get initialized here, except for this one that doesn't need to be initialized. This one, I mean, it's a property. It's a getter that runs code, and it just says, well, however many items, however long my array is, that's my maximum. So I don't need to like initialize this. There's no field to initialize. Oh boy. All right. So now it actually ought to give us, yeah, there we go. So weight, volume, count. I'm going to do that for a little better alignment. It'll look a little prettier. All right, so now I can add an arrow. Arrow's been added. Now you can see like the weight's gone up, volume's gone up, count's gone up. Sword. If I type in garbage, I don't have any banana in stock right now. Bow. It doesn't fit in your pack right now. And you can see like where I'm at. Like there, now I'm out of space for arrows. These little again, this is the whole like user input thing. Like that is these are just the mathematical, the imprecision of a double. We like it might be better to round that somehow, or to even like sometimes in like if we use a decimal for these, then because all of our numbers are like they make sense in a decimal form. If we used a decimal for these, then they would come out even. It's slower. So how much does it matter? Maybe some. Anyway, I'm way off in the weeds here, but and I think we've covered everything. I do want to say to kind of wrap this up, like this is plenty, but I will say that this is a big challenge, and I've seen a lot of people struggle with this one. It's like it's just a lot of moving parts, and I think that like working through this logic again, it's kind of beside the point of the challenge, which is just about inheritance. But I think that this sort of like algorithmic thinking is still a useful thing to do, to like think through like how am I going to do this. And like I said, I think it actually is it's harder by using arrays instead of lists, which we haven't gotten to yet, but we'll get to. But it also, I think that's a good mental, like I said, mental strength training to like build those mental muscles of thinking about these things. So I don't think that's bad. Like I said, this I've done a fair bit of user input here. Like you can see, I've got from line 3 to line 42. So 40 lines of code. That's just about user input. And I went like as simple as, as simple as you can, really. Like it doesn't get a whole lot. Like you could do so much more with user input than this. But this is where we're at. So this is definitely a big challenge. It's also one that I've seen a lot of people struggle with. But yeah, I think it's a good exercise with all the caveats we talked about here in this video. So I think that's it for this time. So thanks for joining me, and hopefully this was helpful. And I'll see you next time.